Good day folks, welcome to my channel. In this video, I'll be discussing about free radicals and their generation. Let's first begin with the definition of a free radical. So a free radical is a molecule or molecular fragment that contains one or more unpaired electrons in its outer orbital. So it is represented by a superscript dot. In this figure, you can see a free radical with an unpaired electron in its outermost orbital. The free radicals, they are also known as reactive oxygen species or ROS. It's because these free radicals, they are formed due to the partial reduction of oxygen molecules to water. And these molecules create havoc to the living system. Now, some of the examples of the free radicals are superoxide anion, hydroperoxyl radical, hydroxyl radical, hydrogen peroxide, and others such as singlet oxygen, nitric oxide, peroxynitrate, etc. These are some of the other examples of free radicals. Now, these are the important characteristics of the reactive oxygen species or the free radicals, and they are their extreme reactivity, short lifespan, the generation of new reactive oxygen species by chain reaction, and damage to various tissues. Here you can see the half-life of the reactive oxygen species or ROS. Now let's move on to the generation of free radicals. So here you can see that they are constantly produced during the normal oxidation of foodstuffs due to leak in the electron transport chain, that is ETC, in the mitochondria. So you know that ETC helps in the formation of ATP, which is a form of stored energy. And about 1 to 4% of oxygen taken up in the body is converted to free radicals. So here I'll be primarily discussing about how the reactive oxygen species are generated in the macrophages, and this take place during the or at the time of phagocytosis. Let's see how it works. So the macrophage and PMN are polymorphonuclear leukocytes. They undergo respiratory burst. Respiratory burst is the increase in oxygen consumption by the body when the macrophages are activated for phagocytosis. So you can see that there is increase in the oxygen uptake, and this oxygen is converted to the superoxide anion radical, and that is with the utilization of energy in the form of NADPH. Now the conversion of NADPH to NADP plus is taking place with the help of the enzyme NADPH oxidase. And this NADPH, it is derived from the HMP shunt pathway with the help of the enzyme glucose 6 peroxidase dehydrogenase. It's glucose 6 phosphate dehydrogenase. So through the HMP shunt pathway with the help of the enzyme glucose 6 phosphate dehydrogenase, NADPH is produced, which is converted to NADP plus with the help of the enzyme NADPH oxidase, and utilizing that energy, the oxygen molecule which are taken up by the body are converted to the superoxide anion radical. Now this radical form can directly have a bactericidal action, which is the process that is taking place here. Or this radical in the presence of superoxide dismutase enzyme is converted to H2O2, that is a peroxide. The peroxide is further converted to hypochlorous acid in the presence of the enzyme myeloperoxidase and with the addition or in the presence of chloride ions. The resultant hypochlorous acid is also having bactericidal function. So by this process, the free radicals are generated to achieve a positive result, and it helps in the killing of bacteria which enters the body. Now let's discuss about one associated disorder in this condition, that is a chronic granulomatous disease or CGD. The thing that happens, or the fact is here, the NADPH oxidase is absent. So there is no conversion of oxygen to oxygen free radical. That is, in chronic granulomatous disease (CGD), the NADPH oxidase is absent in macrophages and neutrophils. So, in this condition, macrophages ingest bacteria normally but cannot destroy them because the oxygen cannot be converted to the superoxide anion free radical. So, however, the strains of bacteria such as Streptococci and Pneumococci themselves produce a H2O2. So, when H2O2 is produced, the further conversion of H2O2 to HClO, that is hypochlorous acid, can be facilitated through the enzyme myeloperoxidase in the presence of chloride ions, as we have already seen, and thus it is having a bactericidal action. But the other strain of bacteria such as Staphylococci, being catalase positive, can detoxify H2O2 in the macrophages and therefore are not destroyed in such persons. Hence recurrent pyogenic, that is pus forming infections by Staphylococci are common in chronic granulomatous disease. So though the Streptococci and Pneumococci strains could be cleared off, the Staphylococci is resistant. Now let's see the various other ways through which free radicals are formed in the body. So one of the causes can be light of appropriate wavelength. They can cause photolysis of the oxygen molecules and that produces singlet oxygen. Or it can be radiations and the cigarette smoke which contain high concentration of various free radicals, and also the inhalation of air pollutants as such do not consist of free radicals, but their inhalation can increase the generation of free radicals in the body. And under hypoxic conditions, the mitochondria itself can produce free radicals. So these are the various other forms through which free radicals are formed in the body. That's it for the video. If you honestly did understand the topic, do like, share, and subscribe. Thank you.